Welcome to Selection with Sathi. Today we tackle classic binary tree problems that appear in every coding interview and GATE CSE exam. We will cover lowest common ancestor, diameter, balanced tree check, mirror and symmetric tree, and all 4 tree views. Each problem comes with code on screen and a complete dry run. Let us begin. The lowest common ancestor of two nodes P and Q is the deepest node that is an ancestor of both. Look at line 2. If the current node is none, or is P itself, or is Q itself, return it. Lines 4 and 5 recurs into left and right subtrees. Line 6. If both left and right returned none, it means P is in one subtree and Q is in the other. The current node must be the LCA. Line 7. If only one side returned a result, propagate it upward. Time is O of n because we visit each node at most once. The diameter of a binary tree is the longest path between any two nodes, measured in edges. Key insight: the diameter through any node equals left height plus right height plus 2. Look at line 8. While computing height, we update a global maximum. Lines 6 and 7 recursively get left and right heights. Line 9. Return 1 plus the max of left and right heights. This is an O of n single pass solution. The naive approach computes height separately for each node, giving O of n squared. Important: the diameter does not always pass through the root. A height-balanced binary tree has the property that for every node, the height difference between left and right subtrees is at most 1. The clever trick is to use -1 as a sentinel value. Look at line 6. If the left subtree returned -1, it is already unbalanced. Propagate -1 upward immediately. This is the early termination. Line 9. If the absolute height difference exceeds 1, return -1. Otherwise, return the actual height. This gives us O of n time, visiting each node once. The naive approach calls height at every node, which is O of n squared. Two related problems: creating a mirror of a tree and checking if a tree is symmetric. To mirror a tree, look at line 3. At each node, swap the left and right children. Then recursively mirror the new left and right subtrees. For symmetric check, look at line 10. We compare two subtrees. If both are none, they match. If only one is none, they do not match. Line 13. Check if values are equal. Then recursively compare left of the first with right of the second and right of the first with left of the second. A tree is symmetric if its left subtree is a mirror of its right subtree. Binary tree views are popular interview questions. Left view: the first node visible at each level when looking from the left side. Look at line 6. In BFS, take the first element of each level. Right view: take the last element of each level instead. Top view: use vertical order traversal and take the first node in each column. Bottom view: take the last node in each column. All 4 views use BFS. The difference is which node you pick per level or column. Time is O of n for all views.
Let us find the LCA of nodes 4 and 5 in tree. Root 1, left 2 with children 4 and 5, right 3 with children 6 and 7. Call LCA on root 1 with P equals 4 and Q equals 5. Node 1 is neither 4 nor 5. Recurse left and right. Call LCA on node 2. It is neither 4 nor 5. Recurse left and right. Call LCA on node 4. Root equals P. Return 4. Call LCA on node 5. Root equals Q. Return 5. Back at node 2, left returned 4, right returned 5. Both non-in. Node 2 is the LCA. Call LCA on node 3, both subtrees return none for 4 and 5. Return none. Back at root 1, left returned 2, right returned none. Return 2. Answer, LCA of 4 and 5 is node 2, their parent. Let us compute the diameter of a tree, root 1, left 2 with children 4 and 5 where 5 has left child 8, right 3 with right child 7. Start from leaves. Node 4, height 0, diameter through it is 0. Node 8, height 0. Node 5, left height 0 from 8, right height minus 1. Diameter through 5 is 0 plus minus 1 plus 2 equals 1. Height of 5 is 1. Node 2, left height 0 from 4, right height 1 from 5. Diameter through 2 is 0 plus 1 plus 2 equals 3. Height of 2 is 2. Node 7, height 0. Node 3, right height 0. Height of 3 is 1. Root 1, left height 2, right height 1. Diameter through root is 2 plus 1 plus 2 equals 5. Global max is 5. The longest path is 8, 5, 2, 1, 3, 7. 2 trees. Tree A, root 1, left 2 with children 4 and 5, right 3. Node 4, height 0. Node 5, height 0. Node 2, left 1, right 1, diff 0, balanced. Node 3, height 0. Root 1, left height 2, right height 1, diff 1, balanced. Tree A is balanced. Tree B, root 1, left 2 with only left child 3 which has left child 4. Right of root is none. Node 4, height 0. Node 3, left 1, right minus 1, I mean 0 from none. Diff 1, OK. Height 2. Node 2, left height 2, right 0 from none. Diff 2. Greater than 1. Return minus 1. Root 1 gets minus 1 from left. Immediately returns minus 1. Tree B is not balanced. Early termination saved us from checking the right subtree. Let us mirror tree, root 1, left 2 with children 4 and 5, right 3 with children 6 and 7. At root 1, swap left 2 and right 3. Tree becomes 1 with left 3 and right 2. At node 3, swap left 6 and right 7. Subtree becomes 3 with left 7 and right 6. At node 2, swap left 4 and right 5. Subtree becomes 2 with left 5 and right 4. Final mirrored tree, root 1, left 3 with children 7 and 6, right 2 with children 5 and 4. Every left-right pair has been swapped. The original tree is symmetric only if it equals its own mirror, which is not the case here. Tree, root 1, left 2 with children 4 and 5, right 3 with only right child 7. For left view, we do BFS and take the first node at each level. Level 0, just node 1. Left view adds 1. Level 1, nodes 2 and 3. First is 2. Left view adds 2. Level 2, nodes 4, 5, and 7. First is 4. Left view adds 4. Left view 1, 2, 4. For right view, take the last node at each level. Level 0, 1. Level 1, 3. Level 2, 7. Right view 1, 3, 7. Simple BFS with picking first or last element. Very clean code.
Quick exam tips for binary tree problems. First, LCA in a general binary tree takes O of n. In a BST, you can do it in O of h by comparing values. Second, the diameter may not pass through the root. Always update a global maximum at every node. Third, for balanced check, use -1 sentinel with early termination. This avoids O of n squared. Fourth, all tree views are BFS based. Left view takes first of level, right view takes last, top and bottom views use column indexing from vertical order traversal. That covers the classic binary tree problems. These 5 problems alone cover at least 30% of tree questions in interviews. For more DSA concept videos with code walkthroughs, download the Selection with Sathi app. Like and subscribe. Thank you.